Thank you very much. The conference organizers have asked our brilliant panelists to keep their remarks short and sweet so that you can have lunch. So now you have our second fascinating panelist.
My name is Delane Richardson. I prepared a really great 20-minute presentation that's now condensed to 3 minutes. And they have a hook over here. If I go over, I don't want to be the first person it's demonstrated on. Very briefly, Chemtex is an privately owned Italian company. We have facilities located in Italy, the United States, Brazil, China, and India. Chemtex is our engineering firm. We began early in the 50s, moved into specialty manufacturing, chemical manufacturing phase, into PET expansion, which took us into Brazil. In Brazil, we have facilities in Sao Paulo, Campinas, Poços de Caldas, and in Suape. We are a total engineering company concentrating in renewables and environmental projects. Along this line, we are capable to do complete projects from beginning to end, from technology development to construction and engineering. Our owners set us on the path of developing a second-generation cellulosic ethanol technology that is now completed. I'll give you a brief description of where we are and then what we're doing with this technology in Brazil. We are competing with oil when it's between $60 and $70 a barrel. We are sustainably environmental from our crop choices. We are looking for something that's going to be profitable for everyone concerned, particularly the farmers. Research and development in Italy, research and development in the United States also. Going beyond ethanol, we're doing quite a bit of work in sugar-based chemicals. We have arrived with a technology now that is lower in capital than we are aware of any of our competitors. We have sugar from cellulosic sources at less than 10 cents a pound, and this puts a gas price on ethanol of $1.50 a gallon U.S. or less than 50 reals per liter. The technology is flexible and it can work a variety of leafy biomass or agricultural waste, which has been the approach we are using to foster this technology in Brazil. Based on, if you have any specific questions, please see me at lunch. I'll be happy to answer it if you're particularly interested in cellulosic ethanol. But we're trying to make sure that we have the agronomy right, which is the biggest challenge in ethanol production. Then we are using both a pretreatment and viscosity reduction step and hydrolysis and fermentation that now has 11 patents applied for. We are able to use both for purpose biomass crops as well as using agricultural waste products. 3 minutes. Okay, so from the chemicals that we're looking at, in addition to ethanol, we are splitting our sugar stream to where we're using both the C5s and the C6 sugars. Furfurols, xylitols, ethylene glycol, propylene glycol are all excellent chemicals. They also fit into our core business, which is PET manufacturing. From the C6 sugars, our cellulosic sugars are being used to make sorbitol, citric acid, succinic acid. These are all of the building blocks that have been designed to replace petroleum for petrochemical manufacturing. You can now make these same chemicals largely from sugars. The trick is where do you get your sugars and how you get the economics correct. Chemtex is in the process of building the world's largest second-generation ethanol facility in Crescentino, Italy. That plant is based on Arundinox and wheat straw as the crop that is going to be converted into ethanol. It is presently under construction. It will be operational this time next year. We'll also be connected with a cogeneration facility that will be applying or providing electricity back to the grid. Okay, particularly with Brazil, we're concentrating on bagasse, where we are looking to use that as an agricultural residue. We're very happy with our cost situation there at less than 50 cents a liter. It also fits in nicely with changing regulations in Brazil that are preventing burning of leafy matter from the cane. So this technology takes both the leftover bagasse as well as the leaf matter from the field and converts it into ethanol. For a Brazilian sugarcane manufacturer, this graph quickly illustrates the potential value that can be arrived from the bagasse and the leaf matter by processing it differently. The first is if it is sold as surplus, where it basically would be burned for energy generation. The second is an advanced electrical energy generation, providing it back to the grid, where we're seeing close to 80 reals per ton of bagasse value generated. The last option is to take that bagasse and the leaf matter and to convert it into ethanol, in which you can get over 170 reals per ton value from the bagasse. This is basically describing the conversion between the bagasse to ethanol, and that we're presently running trials with samples from Brazil today at our facility in Crescentina. So how are we fostering this technology in Brazil? We've developed the technology in Italy, and now we're marketing it around the world. The trick to really fostering it in another country is to determine what their feedstocks are, what the present use and value of those feedstocks are, and how to get your process accepted. We will work with we are collaborating with present ethanol manufacturers in Brazil. We will design for them a process where we can complement their present manufacturing with a second-generation cellulosic facility. We are, without a doubt, the preferred supplier from a CapEx and OpEx. We have feedstocks flexibility. It's unique. We have 11 patent applications pending. We have a considerable amount of experience. We've been running a 1 ton a day developmental line in Italy since 2009, and we had the commitment and the want to be there. And we're ready. If you have any specific questions, please see me during lunch. How's that?
I thought you were fantastic.